All right, we're going to split this assignment in half so that we do the first 5 problems today and then the next 5 tomorrow. So let's take a look at this. So one of the main things that you have got to focus on is what is the population claim and what are the results of the sample that we're comparing to that original amount. So that's one of the first things. That's why we cannot just skim the reading of this. We have to understand what it's saying. We can't just look for numbers. I had somebody who put down 0.22 and then put down a 6, and I'm like, okay, this is 6 has nothing to do with this problem except for that it's just identifying that it's about children under the age of 6. Okay? Anyway, so here we're talking about we are talking about American children under the age of 6 and the proportion of them that are living at the official poverty level. 22% is the current American claim. So we take a sample of 300. Now, remember that we know that this mean of the p hats is always going to be the same as the population, because what that is saying is if 0.22 is true, then all the p hats should be centered at that claim. Okay? If 0.22 is true, then the mean of those p hats will be 0.22. Okay? And then here's that variability. Here is that 0.22. This comes from 1 minus 0.22 and then over n. All right, now this is the sample results. So they get a sample of, see, 19% of the sample. So that's your p hat. So what that's saying is, hey, they got this little p hat right here, okay, that's 0.19. One thing that this question doesn't even ask is I'm curious, is this an unusual amount? Is that 0.19 way far away from the expected amount of 0.22? Or is that 0.19 just because of sampling variability? You get different data than me because of sampling variability. So that's why we get a z-score, plus that we need a z-score to answer the question about the probability. So here we have that with our z-score here. So this is our p hat minus the mean of the p hats over that standard deviation of p hats. So look, my sample of 0.19 was just about 1.25 standard deviations below the mean. Not a big deal. Now, this question asked, what is the probability? So that's a probability. We're doing P word. We're norm CDFing this, that we want to go more than. So therefore, I know I want to do this area here. So the z's are greater than negative 0.125, and that's how we get our norm CDF from negative 1.25 to positive 99, and then there's our answer. Okay, so here's this one. Now, currently, the claim is that 80% of the vehicles on the highway exceed the speed limit. So that's why that's the P. That's the population claim. So if that's true, then all of our samples would be centered at, so the center of all of our P hats, the mean of all of our P hats, would be centered at 0.80. Okay. So then, we get our standard deviation here, 0.80. This comes from 1 minus 0.80 over n. Okay, but here's where you need to kind of use your brain about things and know number values. So here it says, what's the probability that a random sample of 50, so here's my sample results, I'm going to be getting my p hat from this information, of cars traveling on the interstate contain less than 32 who are exceeding the speed limit. So do not think that this answer here is just 32. nor is it 0.32. No, that 32 is 32 out of 50. So that's how you get that proportion. 32 out of 50 is 0.64. So that's what I'm doing. That's what I'm interested in investigating. I want to investigate this p hat right here at 0.64. So here we go. Here it is, p hat at 0.64. So see, I need to see how far away is the sample I got from what was kind of expected to happen here at the center. So I z-score it. My p hat, see how far it is away from the claimed center in terms of this many standard deviations. Negative 2.81. Wow, that's unusual. See, so here's what that's saying, besides what the question is asking. A p hat all the way down here tells me, whoa, I'm not so sure I would have gotten this sample if this is correct, because that was really unusual. This was not just because of sampling variability. Something's happening, meaning I do not think that the samples are really centered here at 0.80 anymore. They are probably centered lower, because it should not have been that crazy to be able to get that. Okay, so that's where we're headed with this, and that's the kind of thinking that you need to have. It's like with our M&Ms. If we don't think that they are centered around 0.24 because we had so many of them that were down there much lower, making it be centered around 0.20. Okay, anyway, this question did ask, what is the probability? So that means I'm going to have to norm CDF to get that area. And I want to go less than. So it is a really small amount from negative 99 up to that negative 0.281, only 0.25%. All right. Next, here we have a random sample. This is a very interesting problem because this one forces you to really pay attention to the context of this problem. You cannot just skim for answers anymore. So this problem doesn't even give you the claimed value first. It says we have a random sample of 65, so therefore N is 65, from Dallas County, and 43 of them. So this is used to get my sample proportion. That is why my p hat is 43 over 65. My p hat, my sample results were 0.66. Then the national U.S. Department of Transportation, the National Highway Safety Patrol, says this is the current rate. That's the current rate. So that is what the population is having. And we want to know, is Dallas's along the lines of that rate, of the national rate? So look here. So this question is saying this: if Dallas County is like the rest of the nation, like the national rate, then all the samples that we get from Dallas County will be centered around 0.77. Okay? So that's what we saw with our M&Ms and everything like that. Okay, so that is why the center of all of the p hats is we set it at the claim. Then we get that sample. And the sample we got was that 0.66. So I'm going to go put that in here. That's down here, 0.66. And so the question is, how unusual was that? Well, is it just sampling variability? No biggie? Not enough to dispute this 0.77? Well, let's see. get a z-score. My p hat, see how far it is away from the national claim in terms of standard deviations. Look, it was a lower outlier. It is unusual. It is very unlikely that I would get that result if the data is centered here at 0.77. Therefore, I don't think the data is probably centered at 0.77. I think Dallas County's center, I'm not saying it's centered at 0.66. I can't do that. I just say I think that this overall thing is shifted a little to the left so that it's not centered around 0.77. So that's truly what this question asked. It didn't, technically, it did not ask this part right here. Okay, so that part really wasn't part of it. I went ahead and I just did the probability of it being lower, but it did not ask that. It simply asked, do you think Dallas County can claim that its rate is substantially lower? Well, and so I said yes. Yes. Since the results we got were a lower outlier, I think Dallas County can claim that its rate is substantially lower than the national rate. All right, so hopefully you're kind of getting the idea of what's going on here. I'm not going to go this in depth on all of the answers. Okay, but I did right here at first because you have got to understand what's happening here. We are not just plugging through math. We are understanding what's going on and why we're saying these things that we are saying. Okay, here we go. So this is saying that according to census data, this is the proportion of adult residences who are Hispanic in that certain county. Okay, so that's 0.19. But they then went and picked people for jury duty, and of the 72, 9 out of the 72 were Hispanic, which is a lower amount than 0.19. So now I rounded this, but you didn't have to. You didn't have to. You could leave it at 0.125 if you wanted to. I rounded it just because a lot of times I tell you round to two significant digits. If you had put 0.125 here, you're going to have a little bit different numbers than I do, and that's okay. So we want to see how far is that sample away from the county's Hispanic rate. Well, that sample is only 1.3 standard deviations below that county's rate. And I'm going to do that real quick. What would it be if I did 0.125, or if I did it with the 0.125? So 0.125 minus 0.90 over the 0.046, that's a negative 1.41. So if you did it the other way, you got negative 1.41. Okay, if you use the 0.125. Then your rate wasn't 9.7, it was something else in that. So that's the probability we would have gotten that much or less. And so 7.93% if you had done the other, kept it at 1.125. Okay, now, so here's another question. Is this sample result making me think that the jury system is unfair? This is a really interesting discussion, because do you know what? If you are going to be in law, if you're interested in going to the criminal justice part of a career, then this can happen. So as a lawyer, they employ statisticians in large firms because they say, hey, the county has 19% Hispanic. So that means when we call a jury to the courthouse, it should be approximately 19% Hispanic. And if it's approximately 19% Hispanic, then we're going to get that about about 19% out of the 72 that we pull. But we got this sample here, 0.125. So is this unusual enough that it makes me question as to whether or not the samples are really centered at 0.19? Is this result just because of sampling variability? Or is that a way far away result to where I question and I think that maybe the data is centered a little lower and they are not truly calling 19% Hispanics to jury duty? If you've got that going on, then law firms can, if you have a Hispanic defendant, you are defending a Hispanic client, and you are hardly getting any Hispanics from the jury pool, then your client is not being tried by a jury of his peers. And you can plea for a mistrial until you can get a more representative sample of jurors that represent your client. Okay? That's what's going on here. That's the kind of ramifications that this data can do for us. So that's why we have to understand what is happening. Well, whether you used 0.125 or 0.13, it was only 1.41 standard deviations below the mean. That could be happening because of sampling variability. You get different data than me because of sampling variability. That is not going to make me freak out and think, whoa, what's happening here? Okay, so I don't think we have the ability to say that the jury system is unfair, that it's pulling an unfair amount of Hispanic clientele to the jury. All right. So there we go on that. All right, you see how these are applying to real life stuff? This is where it just really gets real, and it makes a difference in real life that you understand what is going on here. Okay, so here we go. This is a poll about health stuff. Do you happen to jog? Well, in fact, this is the truth. So 8% of the population jogs. Therefore, this is 0.08, not 0.8. Okay, so watch that. Do not put 0.8 there. 0.8 is 80%, not 0.08. Okay, so then the interesting thing, what is the probability? So we're going to be norm CDFing between two z-scores, that between 13% and 17%. So those are two p-hats. I need to get a z-score for 0.13 and a z-score for 0.17. And once I do that, then I'm going to be norm CDFing that between those two z-scores. Okay? All right. So then that's how we get 3.17% of clients, of Americans, of the samples, sorry. 3.17% of the samples would have between 13 and 17% jogging. All right, that's the first 5 questions. So I'm going to stop the video and start the next one. So I hope that this helped you kind of understand what's going on. I probably won't spend as much time explaining in the next video, but I just felt like I needed to make sure that you have this conceptual idea of what is happening. Once we lay that groundwork of what's happening, then it just is the same thing over and over again, and it makes sense to you. All right. Good luck to you, and I'll see you on the next 5.